Costa High School, and we're going to talk a little bit about trigonometric functions of angles. So here, just to give you some basics on the angles that we're going to be using in trigonometry. When we have an angle, we have something called the initial side and the terminal side. So where the first ray begins and then rotates to the terminal side. So this would represent a positive rotation of 50 degrees. Positive rotation is counterclockwise. So on the second picture over here, we have the initial side, we have the terminal side, and the angle is rotated down. So that means that it is a negative angle. So this angle is roughly negative 45 degrees. Over to the last picture, we have the initial side on the bottom, the terminal side, but if we look at the amount of rotation, it goes a full 360 plus another 40 degrees. So this angle is a 400-degree angle. The next thing I want to talk about is what's considered standard position for angles. And standard position is when your initial side is on the positive x-axis. And positive rotation, again, is counterclockwise. So this represents approximately a 140-degree angle. Here's your initial side. You could have a positive rotation of 250, or you could say, if you went this direction instead, that would be a negative 110-degree angle. On the third picture, it's right on the negative x-axis. So if you went around counterclockwise, that would be a positive 180. And if you went counter, that would be a negative 180-degree angle. The next thing we're going to talk about is the unit circle. And a unit circle is a circle whose radius is 1. So we have the origin here at 0, 0. And here's my initial side, my terminal side of my angle, rotating around. And if I take this point here and go over x and y, from the Pythagorean theorem, we know that x squared plus y squared would equal r squared. And since our radius is 1, if we substitute that in there, we would have x squared plus y squared would equal 1 for every value along the edge of our unit circle. So next we're going to take all of the trigonometric functions we've been working with and use them in a unit circle. So if you look at the picture down below, we have this point xy on the edge of our circle. So over x, up y, radius of 1. And you can remember sine is defined as the opposite leg over the hypotenuse. So using this picture down here, the opposite leg would be the y. And the adjacent leg would be x. And your hypotenuse is your radius. So sine can be redefined as y over r. Y is the opposite, r is the hypotenuse. And since r is 1, y over 1, so sine theta in a unit circle is equal to y. Going through the same thing then, cosine theta, which is adjacent leg over hypotenuse, gives you x over r, but r again is 1, so x over 1. So cosine theta in a unit circle is equal to x. Going on, tangent theta, opposite over adjacent, which is y over x. Assuming though that x cannot equal 0 or it would be an undefined value. Cotangent, adjacent over opposite, x over y. Secant, hypotenuse over adjacent. Again, hypotenuse is your radius, your adjacent is x, but with radius of 1, we end up with 1 over x. And the last one, cosecant, is hypotenuse over opposite, r over y, but with r equal to 1, we get 1 over y. So those are your definition of trigonometric functions in a unit circle. So to use some of these new definitions, we're going to try to find, we haven't been able to find what are called quadrantal angles before. So we're going to try to find all 6 trig functions of a 90-degree angle. And on a unit circle, we have 1, 0. Up here we have 0, 1. And then on the other side we would have negative 1, 0. And down at 270 we would have 0, negative 1. So for 90 degrees, our x value is 0, our y value is 1, and our radius, since it's a unit circle, is 1. So sine of 90, y is 1, radius is 1, sine of 90 is equal to 1. To continue then, cosine x over r, x is 0 at 90 degrees, r is 1, so cosine of 90 is 0. Tangent, y over x, so 1 over 0. Oh, can't have 0 in the denominator of a fraction, so tangent at 90 happens to be undefined. Now we could use our idea about reciprocals, but cotangent then is 0 over 1, which is 0. Secant is r over x, so 1 over 0. Oh, there's another undefined value. And r is 1, y is 1, so cosecant is 1. So if you look, sine of 90 is 1, and so is its reciprocal. 0, when you take its reciprocal, it's undefined, or undefined's reciprocal is 0. So we're going to try the same thing with 180 degrees. Again, unit circle, so that tells me that r is 1, the radius is 1, and the point over here at 180 degrees on your unit circle would be negative 1, 0. So going through, so there's your x, there's your y, sine, y over r is 0 over 1, which is 0. Cosine x over r, so negative 1 over 1, which is negative 1. Tangent 180, y over x, so 0 over negative 1, which is 0. Cotangent x over y, so negative 1 over 0, which is undefined. You can read that. R over x, 1 over negative 1. So secant of 180 is negative 1. And cosecant r, which is 1, y, which is 0, cosecant is undefined. Okay, the next thing I'd like you to do, I'd like you to approximate the value of sine and cosine. Using this picture that I know is kind of hard for you probably to see on your board. So 160 degrees is right there. And I gave you the coordinates of that ordered pair approximately. Approximately 160 degrees if you draw down to the x-axis, and then up on the y is negative 0.94, 0.34. So if I know the approximate coordinates of 160 degrees, I should be able to approximate the value of cosine and sine. Because remember, cosine is x over r, and sine is y over r. And again, we're on a unit circle, so r is 1. So, to approximate these values, the cosine of 160 is just the value for x, which is negative 0.94. And the value of sine is just y, which is 34 hundredths. So, using that idea to approximate cosine and sine of a negative 40 means you're going down 10, 20, 30, 40 degrees. So you're going down to approximately there. So if you make your little right triangle, this point here is approximately 77 hundredths and negative 64 hundredths. So can you find the values for approximate values of cosine of negative 40 and sine of negative 40? Sine So it's approximately, and sine of negative 40 degrees is approximately 4. Okay. Okay. Next, using the same type of a picture, it's just a unit circle. The divisions are intense. I'd like you to figure out which is larger, sine of 80, cosine of 80, sine of 110 or sine of 290, cosine of 20 or cosine of 40. Okay, so sine of 80 and cosine of 80. 80 degrees is up there, and by the definitions on your unit circle, sine is y, cosine is x. So if you look at 80 degrees, if you do your x and your y values, your y value is much larger than your x value. In fact, it's at about approximately 1700ths versus 9800ths. So that means that sine of 80 degrees is larger than the cosine of 80. On sine of 110 and sine of 290, 110 is about there, and your 290 is there. And if you first might think that these would be equal, except for here on the sine of 110, your y value is a positive number. On sine of 290, your y value is a negative number, which means sine of 110 has to be larger, because a positive number is going to be larger than your negative number. Sine of 110 is going to be a positive number, approximately 0.94, and your sine is going to be a negative number. So sine of 110 must be larger than sine of 290. The absolute values would be the same, but the positive is greater than the negative. And the last one I asked you is cosine. And we have a 20-degree angle and a 40-degree angle. And with cosine, you're worried about the x value. So at a 20-degree angle, your x value is larger than at your 40-degree angle. So here your x value comes all the way over there. At 40 degrees, it only comes in about to there. So cosine of 20 is larger than cosine of 40. Next, we're going to talk about reference angles. And it says, let theta be an angle in standard position, and it's not a multiple of 90 degrees. Your 90-degree angles are your quadrantal angles, and so they don't have reference angles, so to speak. The reference angle associated with theta is the acute angle, and it has to have a positive measure formed by the x-axis and the terminal side of the angle. So in this first example, we have a 135-degree angle. It is in the second quadrant. So if we take that terminal side and we just drop something straight down to that x-axis, this angle in here, I'll just call it S for right now, that is your reference angle. So in this example, this angle here would be, there's 135 to the terminal, you're going to the x-axis, which would be 180 degrees, so your reference angle would be a 45-degree angle. In the next picture, we have a 220-degree angle. We still always go to the x-axis. So even though we're down here in the third quadrant, we're going to go to the closest location to our x-axis, and our reference angle then would be this little angle formed by the negative x-axis and your terminal side. And for this picture, that would be a 40-degree angle. Because again, we're going to the 180-degree side, so those are 40 apart. Just like this example, those were 45 degrees apart. In the last example here, I used a negative angle. And we're down in the fourth quadrant. So terminal side, the closest x-axis would be up to it. So this angle here would be our reference angle. But remember, reference angles are always positive. So the measure of that reference angle would be a positive 45-degree angle. So when you use reference angles, you always either go to 180 or 360, which is also 0 degrees, to find your reference angles. The next thing I'd like to do is find the signs for each of our trig functions in each one of the quadrants. So, going through this, sine is y over r, cosine, x over r, tangent, y over x, cotangent, x over y, r over x, r over y. And r is always a positive number. If we're talking unit circles, it's a positive 1. So in this chart, first quadrant, to get to the first quadrant, you have to go positive x direction, positive y direction. To get to the second quadrant, you go negative x direction, but positive y direction. The third quadrant, negative x and negative y. And fourth, positive x, but negative y direction. So for sine, for the first quadrant, since x and y are positive and r is positive, all of these, we're going to go positive over positive, all of these are going to be positive values. Because you always have a positive number if you're in the first quadrant. So in the first quadrant, all 6 functions will always give you a positive value, because you're only dealing with positive x, y, and r values. But in the second quadrant, again, this is your x, this is your y. The sine, y over r, would be a positive over positive. So you'll always have a positive value for sine in the second quadrant. Cosine, though, your x is negative, r is always positive. In the second quadrant, cosine will give you a negative value. Tangent, positive y, but negative x, will give you a negative value. And then all the reciprocals will have the same as theirs. So let's see, secant would be positive over negative, and r over y would be a positive over a positive. So in the second quadrant, there are only 2 of the 6 trig functions with positive values, and they are sine and cosecant. So sine and cosecant. In the third quadrant, x is negative, y is negative, but r is positive. So we have a negative over positive, which is negative. We have a negative over positive, which is negative. But here we have a negative over negative, which makes a positive. Negative over negative, which is positive. Positive over negative is negative. Positive over negative is negative. So in quadrant 3, again, we have 2 of them with positive values, and they will be tangent and cotangent. And we have 1 quadrant left, fourth quadrant. X is positive, but y is negative. So sine would be a negative over positive, which is negative. Cosine would be a positive over positive, so cosine is positive. Tangent would be a negative over positive, so negative. Cotangent would be positive over negative, so a negative value. Secant, positive over positive. Oh, there was another positive one there. And the last one, positive over a negative, is negative. So quadrant 4, cosine theta and secant theta will always give you positive values. The other 4 will give you negative values. Note, quadrant 1, they're all positive. 2, sine and its reciprocal. 3, tangent with its reciprocal. And 4th one is cosine and its reciprocal. So 2 of them are always positive in any one of those other quadrants. So we're going to try evaluating now using our reference angles and what quadrant we're in. So a 135-degree angle would be in your second quadrant. So that should already tell you something about the positive and negative values. Second quadrant, sine and cosecant are positive. The rest I can fill in with a negative value. And if this is a 135-degree angle, we want to use that reference angle now, which happens to be 45 degrees. So if I come down here to a basic 45, 45, 90 triangle, we know from before that the legs we can represent with 1, and the hypotenuse would be square root of 2. So we can just use now our 45-degree reference angle with our positives and negatives. So sine would be 1 over root 2, so root 2 over 2. Cosine is adjacent over hypotenuse, so negative root 2 over 2. Tangent opposite over adjacent, adjacent over opposite. We have hypotenuse over adjacent, and hypotenuse over opposite. So it looks just like our regular 45-degree answers that we've done before, but we're in the second quadrant, so sine and cosecant are positive, the rest are negative. So would you try the next one for a negative 120-degree angle? Okay, so let's start by figuring out where a negative 120-degree angle would be and what the reference angle would be. So negative 120 would be 90 plus 30 more there. So this is our negative 120-degree angle. But remember, you always go to the x-axis because you always do x, y when you do coordinate pairs in that order. So the reference angle here is we would have to go 60 more degrees. So to find the trig values of these 6, all we're really worried about is the trig values of a 60-degree angle, but in the third quadrant. And if you remember the third quadrant, tangent and cotangent are the only positives. The rest I can fill in with negatives. And the basic 30, 60, 90 triangle, crossing the 30 is 1, hypotenuse is 2, crossing the 60 is square root of 3. So, sine of 60 is square root of 3, so the sine of negative 120 would be a negative because it's in the third quadrant. Cosine is 1/2, tangent, root 3, cotangent would be 1 over root 3, so root 3 over 3. Secant would be 2 over 1 or 2, and cosecant would be, oops, I left off a number here, sorry, square root of 3 over root 2, would be 2 over square root of 3, so 2 square root of 3 over 3. Okay. Next. The last thing I would like to work with here today is the area of a triangle. And we know that area of a triangle by the basic formula from geometry is 1/2 base times height. But we don't always know the height of a triangle. Sometimes it's easier to measure the lengths of the sides and possibly the angle. So given this information here, if B is the base, A is some side, and theta is the angle between those two sides, we can come up with a new formula for area of a triangle that's a little more convenient to use. So, using this angle, I know the sine of theta, sine is opposite over hypotenuse, so in this little right triangle, it would be h over a. So using this right triangle, sine of theta is h over a. And if I cross multiply that, h would equal to a times sine of theta. So the hypotenuse of the triangle is always this other side times the sine of the angle. So I'm going to take that and substitute it in there, and maybe just do a little rearranging. So I have a 1/2, I have a b, I have an a, and a sine theta, and usually the formula is just written in that order. So that's our new area formula today. It's a formula we can use if we know side, angle, side. So we know one of the sides, the angle in between, and then the next side. And it's 1/2 side length times the sine of the angle between them. And it also works if it's an obtuse triangle. Because if I say have a 110-degree angle, its reference angle is 70 degrees. And sine of 110 degrees, sine in the second quadrant is positive, and sine of 70 degrees is positive because it's in the first quadrant. So both of those angles actually have the exact same sine value. Sine of 70 and a sine of 110. Because to find the sine of 110, you would use your 70-degree reference angle. And so by the same thing here, if I have this angle, and I'm looking at this little triangle in red, so this triangle I just wrote over in blue, so the sine of 180 minus theta, which would be that reference angle, is equal to h over a. So a is equal, h is equal to a times the sine of 180 minus theta, but we know that's the same as the sine of theta. And so it will give us the same area formula when we substitute it in here for h. Your area would still be 1/2 AB sine of the reference angle theta. So here, if we try to find the area of this triangle, we don't have to find any other sides. We know the area is 1/2 the side, and the sine of the angle. So the first thing we need to do is find the sine of 120. So if I think about a 120-degree angle, it would be in quadrant 2, and it would have a 60-degree reference angle. So the sine of 120 is the same as the sine of 60. Again, sine is positive in the first and the second quadrant, and the sine of 60 is square root of 3 over 2. So if you kind of envision this triangle here, if this is 60, this would be your square root of 2. This is your hypotenuse, which would be 2. The only difference is this value here, across from the 30, instead of being 1, would be negative 1. But that doesn't change the sign, because sine is y over r. So if we multiply this out, so 1/2, 32, 28, and then we're going to put in square root of 3 over 2. That value is equal to 224 over 3, or approximately 387.8 centimeters squared. So, thank you very much. That's the end of your lesson for today.